Let's start with, we are going to discuss about group by, having class, order by classes, you then set union all. These are called as set operators. Then we'll see joins and subqueries. First, let's start with group by and having class. So what is group by class? Group by class is used to group the records, similar records into, and then we usually get a summary rows from that after grouping the records. That is, if we wanted to have like group something, means putting all those with the same value in one group. Like say for example, let me show you an example. Say for example, I have something like a product, some Sony, and then you can see something like Samsung, again maybe Sony, like this. Say for example, I have something like this. Then we wanted to group similar items. Like if I wanted to group, what does group mean here is, we wanted to group the similar items. So if you observe, let's say for example, we have a table of two columns with something called product name and the quantity of this product ordered or sold. So we wanted to group this table by this product name. Let's say for example, we wanted to group this table results into, we wanted to group these results by product name. First column is product name, second column is the quantity, number of the quantity ordered. Let's say for example, those are the number of quantity ordered or sold. We wanted to group. So what does group means is grouping similar items. Say, so what are the similar items here? You can clearly see the similar items here in this table are, you can see two entries here, right? So this we can actually group, and we can group these two. These are the similar ones. So likewise, actually these there are three Sonys, so we can group all these three into one. So we can say Sony, and then if we wanted to perform some operation on this group, so we can group it by some operation. Like we can perform some, we can use some aggregate functions. This we discussed last session. So you can say here, like if we wanted to find the sum of all the items on product Sony, so you can see it here, 4, 5, and then 3. So if we wanted to the sum of all this, we can just say sum of all these items is what we can say. But what we are doing here, we are grouping so that this whole table results will be converted into, how it will be converted is Sony. Then what are all the Samsung items? So that will be grouped into like one entity. And Samsung, all if you wanted to do a sum on that, so sum of all the Samsung here, there can be some item Samsung, that all can be grouped and can be written as one row here. And then all the LG ones, the similar items, and we can perform some aggregate function on that, or aggregate function, or we can order in some something. So we can perform some aggregate functions on that by grouping the similar items. So that is what we mean by grouping the items. So with that, what happens? You might have multiple rows in your table, but with grouping by, what happens is, when you group by some column, say for example, in this case, we are actually grouping it by some product. So what happens is, we can actually analyze the results easily by products in this example. Likewise, if you wanted to group by some column, you can actually view the results by that column name. And then whatever you wanted to perform some operation on that group, you can actually have that in your query, so that you can easily analyze the results in your table. Maybe your table can have hundreds of entries, but if you group by this some column, then you can actually view the analytics or aggregation, or if you wanted to have some operation like sum, or if you wanted to find some maximum of something, some items, that you can actually view it here. So this is the use of grouping the items or grouping the rows. So if you observe, we are grouping the rows. we can have multiple rows here. So we learn like from top to bottom we read them as rows, and each piece of information is called one column. So all the columns, so if we have some information in all the columns, so that is one row for us. So we wanted to group these rows, and how we wanted to group these rows, we wanted to group them by some similarity. So if we take this, in this example it is product, so there is something common in it. So we wanted to group them, and there can be some other column, so we wanted to perform some operation on that column. So that operations, for that operations we can use aggregate functions. So this is the use of group by. So we'll see now how it works. So you can see here the group by class groups records into summary rows. So finally we'll group records the similar values whichever are there for the rows, and then we'll have the summary rows for them. And you can see group by returns one record for each group. So just now we discussed. So finally after grouping what happens, we'll have one row for it. All these are similar, and we'll finally have one row for it. Group by typically involves aggregate functions. Just now we discussed why we usually group by is to have some analytics on the table or on the products. Group by can group by one or more columns. So we can group by one or more columns. Like the similarity can be, say for example, you can group by more than one column. What does that mean is, say for example, Sony. This can be black and white, and then say for example some number here. Then again Sony, it can be color. I'm talking about some TVs here. So it can be 5 quantity. Then Samsung, black and white. So if you observe, Sony black and white, Sony color. So these two are like, we there can be another entries. So we wanted to group by two columns. So the entries we are taking more than one column, whichever is common for us. So we will be looking into the combination of these two columns, and we'll be grouping based on that condition, and we'll be performing some aggregate operation on that columns. So this is what we mean by aggregating on more than one. So only grouping by one is taking one column value and looking the and performing some operation on another column, right? Grouping by more than one column is we look for the similarity of more than one column, like this. So that is what we mean by grouping by one or more columns. Now we'll see some examples on that. Let's first look into product order details table. So we have classic models schema. We discussed how to import that schema into our database, MySQL database. Now I'm going to show you the order details table. So let me right click on this, select rows. You can see the rows here. Like there are like some around 3000 rows in it, and this order details table has order number, product code. Order number is the actual order number for this order, and let's see what the order is. So in this order there is a product code. So there is a product order of which the product code is mentioned here, and the number of quantity ordered was 30. You can see it here, and price of each quantity, price of each unit is this much, 136, and some order line number here. So this is what the order details table has. Now what we wanted to find here is, let me take this entire thing here. Just look only at this one, at this first query. You can see it here. We wanted, so this is the table. We wanted to group by the product code, and we wanted to find the sum of the amount, which can be, which is the payment. See for example, this is the product code, right? And if you observe, this is the order number. One order has one product code. Like this there are number of order. So for each order there can be a different product, but what we wanted to do is we wanted to group by the product code. There can be different products here. You can see different products, but one or more customers can order same product code, same product. So now we wanted to calculate for each product, what's the selling value? What is the selling value for this? If you observe, so if you take this product code S18 underscore 1749, there is quantity 30 and price of each unit is 136. So how do you calculate the total value for this? Price of each unit into quantity ordered, 30 into 136 will become the total selling value for this product code only for this order, if you remember. Notice that. And we wanted to actually group this product and find the sum of it. What's the meaning of that is, so if you click on this product code column here, so it will sort. So you can see it here, all the columns got sorted. So now what we wanted to find here is, let's say for example, let's take this product code. So if you observe, there are like more than one order who has ordered same product. Same product. There are like many customers who ordered the same product. But what we wanted to find is, so how much this product made, how much this product made, and what's the total selling value of this product. Likewise, there are many products. So till here it is one product. Then another product starts. So there can be more than one customer who ordered more than one who ordered this product. Like there can be more than one customer who ordered the same product, and we wanted to group by all this as one entry and find the sum of all this selling sum of all these items. And how to find this sum? So each unit into number of quantity ordered. So we'll multiply that, we'll get the selling value, and then we are going to group by the product code. So even though you see it is here a code, so just consider that as a one product. So you can see here now what we wanted to do is, we have like many orders with the same product code. We are going to have one value for this, and what are we going to do is, we are going to find the sum of that value of for this product. For that, how we can find that is, you can see it here. Just look at the query which I highlighted. Select product code. I wanted the product code, and what I wanted to display is sum of quantity into price each. So this gives the selling value for the product for that order. So there are price each is one unit price, and the number of quantity ordered is like 30. Like it can be number of units here. Number of units into each price item gives us the actual selling value, actual total price for that order. So that we wanted to look into it, and from this table order details, group by product code. So what does that mean is, what is the sum of the all the orders for this product is what we wanted to calculate. For all these entries, we are going to group it as one, and we are going to find the sum of it. So how will the sum be calculated is, 30 into 81.35 plus 34 into 86.13 plus 41 into like this 90.92, so on till all the entries for this product is done. See, till here all this will be calculated, and we'll get one entry as this product code, and the next column shows us the actual sum of all this for that product code. So for that, we need to write the syntax like this. The SQL query is, select, I wanted the product code, sum of the quantity ordered into price each from my table order details. I wanted to group it by product code. Grouping it by product code is similar products. All similar product will be grouped, and we'll have only one entry. We'll have the summary row for it. So let me execute this now. And you can see it here. So you can see it here, each product, it is not repeated now. And you can also see it here. There are 109 products, different products. So you can see here 109 different products. We have it, and each product has made this much amount. Like each product, we can see the product code here, and on the right side we are calculating the sum of the like selling price of that product. So this product made the selling value of this much. This is the amount on the right side. So like this, we can actually group by some product and find the sum of that some of the value of that product. So this is about like grouping by some column. Now we'll see another example here. So same order details, what we wanted to find here is, let me execute this again, this order details table. You can see here for the same order, in the same order, there can be more than one product bought. So if you observe, this is the same order 10100 is one order, and within the order there were like four products sold, four products bought by within this order. Maybe some customer has bought like has placed an order with four products, and this is the quantity ordered for each product, and price of each is this. This is fine. Let's look into this. So this for the same order, so we have like four different products order. So now what we wanted to do is we wanted to group by order number. So group by order number, like even though we have four entries here, I wanted to have one entry like as the order number is like repeated here, I wanted to have one entry, that is for each order what is the average price. So for each order, what's the average amount getting sold is what we wanted to find. Now how to find it? We'll group by order number this time. Last time we grouped by product code. So this time if we group by order number, then this four entries will become one, and we are going to get the let's say for example sum only. Sum we know how to calculate, quantity ordered into each price. So this is how we can get the sum of each order, sum of each order. Now let's just for difference, just for I wanted to show it in a different way. I wanted to just use some other aggregate function avg. It gives us the average price. So for each order number, so we are going to calculate the average price. So what's the average price of order numbers is what we wanted to find, or else you can just find the sum also. So you can see the same query we have written, but this time we are grouping it by order number. So let me execute this. Last time we grouped by product code and saw the and found like some of the value selling price of that product by product code. Now we wanted to group by the order number and find the average of the selling value. So you can see it here. Let me execute this query, and you can see it here. This is how it will be calculated. For this order, this is the average price, and for this order, this is the average price. So average price is simple. So it is like sum of this one, 30 into 136, 50 into 55, 22 into this, like this, and then divided by 4 gives us the average value. That is what this is. And if you are not getting this, then you can just replace it with sum and we can understand it. So you can see it here. This is the sum of the order, like whoever placed order and who has the order of 10100 should be paying this amount for his order. And the next order is this. So this order, whoever has placed this order with this order number should be paying this amount for this order, for their order. So this is what we calculated here. And this is the use of grouping by. So grouping by groups the similar values into rows, and we can have the summarized results. So this is how we can use the group by on one column to group by that column which has similar value, and we can actually implement some operation on it. Like mostly we'll use aggregate functions to group the similar items. And you can see another example here. We wanted to actually find the, for each order number we wanted to find, we just found the sum of the sum of the price, right? So sum of the selling price or the total price to be paid for this order number. Now we wanted to find the maximum order, like what's the maximum value and what's the minimum value. That is, how do we calculate? That is, we actually calculate like whenever we wanted to find the total price, we just multiply the quantity into each unit, so that we'll get one value, right? From that, we wanted to find what's the maximum and what's the minimum value for each order. Let's say, let's only take one order here. So if you take only this order, within this order, we wanted to find what's the max and what's the min order. You can see it here. What's the max and what's the minimum order for this order. And you can clearly see we are grouping by order number here. So just that we found some, like that we are finding the max and minimum value here for each order number. So for that we need to group by order number. So let me execute this query, and you can see it here. For each order number we have some maximum and some minimum. So there will be like for this, at least for this order, we'll be getting 4 values. Out of that, this is the maximum value and this is the minimum value. Like this we can have a number of orders, right? So you can see it here. For this one also there are like 4 or 5 entries. 10102 has only 2 entries. Like this, each order number will be grouped, and for each order we'll be finding the maximum and minimum value from that orders. So for that we can use the max and min aggregate functions. Next, we wanted to find the employees by the office code. So each office has how many employees, we wanted to find that. Let me open the employees table here. You can see it here. I just right clicked on this table employees, which is present in classic model schema, and you can see the data here. So there are like 23 rows in it, and you can see employee number, last name, first name, extension, email, office code of each employee, and who the employee number, the manager number, so the employee who reports to. So this is the number of the manager who this employee reports to is specified here, and then the job title or designation of this employee. So this is the employees table. Now what we wanted to find here is, we wanted to find out of this table, there are like office codes. So each employee, there can be more than one employee in one office, right? So we wanted to find the count of the number of employees in each office. You can see there are like office code 1 has like 3 employees here. Again there are some more entries, 1 1. So like this we wanted to group by office code and find the count of the employees in each office. That is what we wanted to find. So for that we can write the query like this: I wanted office code and count star. Count star gives us the actual value, what's the total number of rows. So I gave some alias here. So alias is just a representation of the column name here temporarily for that execution. From employees table, group by office code. So if you observe group by office code, what happens is, so let me sort this. So on this tab, if you just click on this, one click, single click, so it gets sorted. Okay, somehow this is not getting correctly sorted, but you can see it here. This is what we wanted to achieve. Yeah, it's sorted. You can see it here. So what we wanted to do here is, we wanted to group this by office code. All this office code, we wanted to find it, like how many number of employees are working in the same office. So all this office code represents same value, right? So for this same value we wanted to find the count. So if you see 3 4 5 6, so office code 1 has 6 employees. Like that there are 2 employees in office 2, 2 employees in 3, and some number of employees in 4. That is what we wanted to find. So to find that, we need to select office code, and then what you wanted to find, we wanted to find the count, the count of the number of rows. So with that we can actually say that how many number of employees are working in that particular office. From employees, group by office code. So let me execute this, and we can clearly see here office code 1 has 6 employees. So in office code 2, or in office 2, there are 2 employees working. In 3, there are 2. Like this, we can find it out the number of employees working in each office. So again, what did we do? We make use of group by class. So group by class, we are grouping by office code, so that we are getting finally the count of the number of employees working in that particular office. Next, we'll see uh, select more than grouping by more than one column. So how to group by more than one column? We'll see that now. So we are grouping by order name and product code here, if you observe. So again, I am using order details table. So we wanted to group by both order number and product code. So this has to be like grouped. So if there are any entries with the same order number and product code, that will be grouped. And we wanted to find the, again, what we wanted to find here, we wanted to find the sum of the sum of the selling price, quantity ordered into price each gives us the total amount of for that order. You can see here product code and order number. We are grouping it by two columns here. So for that, so we wanted to display this product code and order number group by both order number and product code. So what we wanted to check here is this has to be like if there are any entries which has order number and product code repeated, that will be grouped. This both two has to be like if these two are repeated, then that will be grouped into one entity, and then sum will be calculated for that. So this is how we can find this is how we can group by more than one column. And you can see here there are uh, all the rows are like unique. So that's the reason we see all the number of rows written, around 3k rows written here, and we can see the sum here. So in usually if we wanted to actually group by more than one column, so how does that work is it actually takes the unique value of this. If this is repeated, both order number and product code are repeated. Say for example, this is 1010 and this has product code as 181749 and order number is same. Say for example, this is also some product code same. This is also for the same product code. Then these two will be grouped and will be made as one entry, and the corresponding operation will be performed. So that is how it works when we group by more than one column. And you can see it here, something here, select product code sum order number. So this is somewhat invalid. Like if you observe, let me execute this. I am grouping by product code and wanted to find the sum of the order. Fine, this is very similar to our first query, but order number I am wanted to display it here. So it is actually invalid. If you observe, this might not actually give you the correct order number. So always the select class should have the column which you are grouping by. So if you observe, in all the cases, if you observe, select class will make sense to have a column which you are grouping by. Only then you will actually get the operation which you are wanted to perform. So always it's a best practice to have, even though in some databases this is even invalid. Like I'm not grouping by order number here, right? So in some databases will not even allow this, but MySQL is allowing this, and this is this you can't make sure that this is the correct order number. So you always need to group by. So whenever you have something in your select class, so you also need to have that in your group by class as well. So let me put it here. Should be part of group by class. This is all about group by class. Next, we look into having an order by class. So having class is used to filter the output from the group by class. So what does that mean is, we usually filter the rows by where class. Whenever we write a select query, what do we do? If we wanted to filter the rows, what do we do here is like we usually write a where class to filter the rows, and where class is a condition to filter the rows. That is what we have seen on a select class. Now having is a class uh, which we need to use on the group by class, and this has to be used. Having class can only be used when you use the group by class. You can't use having class anywhere else. So we can only use having class when we use the group by class, and the functionality of having class is similar to the where condition. So once we group by some column or one or more columns, we can filter the summary rows by using the having class. So that's the definition. You can see it here. Let me take this. You can see it here. So what we are going to do here is, till here we know what the query does. It is actually grouping by the order number, and actually we are finding the sum of the order, sum of this order. You can see here we are grouping by order number, and we are finding the sum of the total of that order. That's the reason we are using sum here. Till here we are fine. But what's the value of this total price? It can be anything if you leave it here, but we are actually filtering it out on the condition. The total price of this sum has to be greater than 50,000 is what we are mentioning it here. And that further to mention it, you can't use where class here. We usually use where class when we write a select statement, but here as we are using group by class, and if we wanted to filter out the results, we definitely need to use the having class. And it's very similar to the where class. You can write any condition here based on the output of your group by class. So let me first execute till here. We'll see. And whatever you highlighted, you wanted to execute that statement, you just need to click on this second icon, execute the statement under the keyboard cursor. All right, now you can see it here. There are how many rows written? There are 36 rows written, and like there are 36 orders, different orders, and we can find the sum of the total sum of the order. For that order we can see it here till here, as we grouped by the order number. This is fine till here. This is fine. Now what we wanted to do, we wanted to write a condition here. We don't wanted to display all the results here, but we wanted this sum of the total price to be greater than 50,000. Let's observe. So you can see here 36 rows written if you don't have any condition. And let me execute the whole query like with condition having total price greater than 50,000, and it also says 36 rows. So let us change the query, having maybe 80,000. No, there are no orders. Okay, let us find which are greater than 70,000. Yeah, if we have 60,000, so there are like only 3 rows written. So or else what was the count? It was like returning us some 36 columns, right? Let me execute only till here. Okay, it is actually taking this whole statement. Let me comment this for now. We are ordering it by, yeah, you can see it here. This is the count, like order number and sum of the total price and we are grouping it by order number. Now we are adding a condition here where we don't wanted the all the total prices of all the values, but we wanted only the total price which is greater than 60,000. That is what we wanted to find here now. And for that, you can see it here. There are only 3 such orders which have the uh, total price or total order value of greater than 60,000. And this is how we can write the query. We just added a condition here. And what did we do? Instead of using where class, we definitely need to use the having class. Just to filter the rows after when group by class is used. Just remember this. Should not use where class. Where class is normal select, but this is select command, select query with group by class. So then definitely in this combination like select and group by, you can only filter it out using having class. And you can see the difference here. So how to use this where class, and so if you wanted to use the where class and also group by, so how do you use it? Where class should be specified before the group by class itself. Like you can see it here. We wanted to find the order number, like and some of the order from order details where order number is less than. So here we can see some order numbers, right? So let's go back to order details. So you can see some orders here, and order number is also some number here. And we wanted to find order number which are only less than this value. So for such values, we wanted to group by order number. So in that case, we can mention the where condition on the order number like this. You can see it here. I wanted the order number and for the sum of it, fine. But first of all, let me filter it out the orders by order number which are less than some value, some order number, then group by the order number. In that case, we can write the syntax like this. First, write the where condition, then group by, and if you still wanted to apply some condition on top of that result, then we can use the having class. Okay, it says, and you can see it here. Okay, order number, we are getting it like this, right? Okay, let's have it as having class here. We are grouping by order number, having group number. Okay, I think just a minute. Order number is integer, fine. Okay, if it is integer, then we can actually apply it like this. So overall, like what I wanted to say here is we can write a having class. Having class is similar to where class, but it has to be followed only by the group class, group by class, and we can't use this having class anywhere else. So only having class should be followed only after the group by class. This is what we need to remember, and you can't use the where class after the group by. So if you wanted to use the where class also, we can use it, but only before the group by. That we'll see now. What's the order of execution? We are going to see it in few minutes. Now coming to order by class. So what's the order by class? Order by class is used to sort the rows in a table. We get the rows and we can't actually assure the order of the rows, right? So for that, we can actually have the order also. We can sort the rows by using order by class. How to do that? We'll see that now. You can see it here. There is a customers table. Let me show you customers table. This is the customers table. It has like customer number, customer name, and some information about each customer. And we can also see something called credit limit. So credit limit of each customer. Now, what we wanted to find here is, so I wanted to, here you can see the credit limit of the customers, and it's not in a particular order. You can observe. So one value is like less, more, then still more. Zero is lesser than 21,000. It doesn't follow any order here. But how we wanted to view the data here is, for the customers, we wanted to view the data based on the credit limit in descending order. So in descending order, that's the order we wanted to display the customer information. So for that, we usually say select star from customers, right? So you can see it here. Select from customers. It actually returns all the rows from the customers table. You can see it here. But fine. But if you observe, the credit limit is not in a particular order. We wanted to sort this rows of customers by credit limit. What does that mean is, we wanted to sort it. Like for that, you can use the order by class on column, and we wanted it to sort it in the descending order. Descending order is from top to bottom, like from maximum to lowest value. And for that, we need to specify this keyword called DESC, which represents the descending order. And as we wanted to sort these rows, we use the order by class, order by some column name. That is what we need to specify it here. Let me execute this. And you can see it here. The credit limit of the highest credit limit will be on the first row now. And next highest will be the second, will be displayed in the second row. Third row will have the third highest. Like this. Like this, if you slowly scroll down, you will get the values in decreasing order. Till the last customer, you'll be seeing the data in decreasing order from maximum credit limit to least credit limit. It is sorted. So for that, what did we use? We used the order by class on some column, specific column, and as we wanted to have it from maximum to minimum, we used DESC. And if you wanted to have it from minimum to maximum, or lowest value to the highest value, then we can use ASC. Now you can see it here. The customers who has the limit as 0 will be displayed first. Like 0 in the sense, 0 is the least value here in this data, and then comes the next least value, and goes on. It from here it goes on increases. So this is how we can view the data by sorting on some particular column. And you, even if you don't use ASC, ascending order, if you wanted to print the order in ascending order, you don't even need to specify this ASC. It is by default sorted in ascending order. That we can view it here in the second example. So I wanted to sort or order my customers table information by customer name. You can see customer name here. So I wanted to have in alphabetical order, and that too in ascending order from A to Z. So for that, I don't need to specify ASC ascending here, as ascending is by default. It actually orders by ascending order. If you wanted to sort it by descending order, then you need to specify this DESC. And you can see it here. I just now executed this second query, and customer name got sorted. You can see it here. It starts with A, L, PH, Alpha, American, like this. So all the customers who has the name in A with A will be displayed first. Then comes B, C. So customer names which starts with C, D, like this. Like this, we can have the customer name sorted. For that, we can use the order by class and mention the particular column name. And ascending order is a default sorting method. So order by, we can use AC and DEC. AC by default sorted, by default order, ascending order. Like this, I can specify here. Now let us see the order of execution. With this, we'll get more clarity on how to use this group by and order by, where to use the where class and all. So you can see it here. First, the order of execution will be where, then group by, and group after group by we'll be using having class, and then finally we can use the order by class. If you wanted to use if we have all these classes in one query, this is what the order of execution is. So you can see here the syntax of it. Select column names from some table name, where some condition, we'll write some condition, and group by some column name. We wanted to group the results by some column name, and when we get the results on that also we wanted to apply some filter. So we already grouped the columns, and now we wanted to apply some filter, so we'll use having class, and we'll write our condition here, and finally on the final result we wanted to use the order by to sort the rows. So finally we can use the order by like this. Let us see some examples on that. You can see here we wanted to, we already know the order details table, we wanted to group by order number here, and wanted to find the sum of the total order, and this is how we write the query fine. And if you observe, having total price greater than some value here, let's take some 60,000 again here, and order by total price. So if you see total price, order by total price, we didn't mention DESC or ESC, so it will be by default in the ascending order. Even though if I do not specify ASC, which is in ascending order, it will by default take in ascending order. And you can see the values are displayed in ascending order: 61,234, 61402, and then 67. So these are in ascending order. So the point to be noted here is, first it executes this query, and it groups by the order number, it gets some results, and on top of that, so if you see here, on top of that, this having class will be executed. Execute this. So you can see it here. This is what the results we get it when we group by order number, and then we'll actually apply this having class on the total price, which has greater than 60,000, and then from that we wanted to order by use the order by class. So if you observe here, it's not in a particular order. Now we wanted to sort this whole result in ascending order on total price, and for that you can see it here. Now it is sorted, and if you wanted to sort it in descending order, we just need to mention the DESC keyword, which represents descending order, and you can see it displays in the descending order. So this is the order. Like first we'll write first group by will be executed. On that, having class actually filters the value, and after on the complete result we can apply the order by to sort the results. And we can see another example like order number sum from this table where class, then we wanted to filter the results on the order number, then we'll group by the order number having, then we'll use having class, finally we'll sort the results by order by class. And we can see it here, there are like 10 such rows which has order number which are less than 10150, and which are grouped by the order number. We can see the total price of it, and which have the total value always greater than 50,000, and which are ordered by the total, which are sorted by the total price in descending order. You can see it here clearly. And this is how the execution order is. First, we can write the where condition to filter out the rows, and from the results, we can actually group by some particular column, and after grouping by, also we wanted to filter out the results. For that we'll use having class, and finally on top of that we can order by or sort by some particular column. We need to know this order of execution so that we can actually write the correct syntax of it. So this is all about order of execution when you are writing the group by class and using having class, and you wanted to order by some particular column. Union operator. What is an union operator? Before that, we need to know set operators. So you might have heard this set operators in mathematics. So in the same way, like we do have set operators in database as well. So these are the different set operators we have: union, union all, intersect, and minus. And though intersect and minus are not supported in MySQL, so let us learn what these set operators are now. So let me show you one example. Say for example, this is one table, table 1, and some table 2. And this union or these set operators, we just now we saw like there are 4 types of set operators, right? Union, union all, intersect, and minus. And mainly why these set operators are used is like to combine the results, to combine the results from more than one table. We use this set operators. So what do we mean by combine? We'll see it now. Say for example, I have some 2 tables, and let's say for example, in my table I have some numeric column, say some number 1, and I have some values like I have 1, say for example 2, 4, some 5, like this. And in my table 2 also I have uh, some column called some num2 or num1 itself, and I have some columns here like 2, 3, some 4, 5, like this. Now let's understand the set operators with this example. So we have 2 tables, and each table has 1 column in each, and these are the different values in it. So each has like 4 rows, and these are the values of these columns. All right. Now let's understand what union does. So when we do union operation between these 2 tables, what happens is the result is, so as I already said, it's a combination of it combines. So when you use the union operator between any 2 tables, it gives us the combined result set of these 2 result sets. So when we use union between these 2 tables, so the result is 1, it will be 2, then union of these 2 by uniquely. Say for example 1, 2, so it has 4, 5 as well, right? So it will print 4, 5 as well from the first table. And if you observe, it also takes the values from table 2, but it will not add it here if it's already present. So 2, 3, 4, 5, 2 is already present, will not display it. 3 is not present till now, so it will print 3. 4 and 5 are already there in the first table, so it will not print anything. So you can see this is how union operator works between any 2 tables. And what did we observe here? There can be values which are duplicates, but that will be eliminated when we actually use the union operator between any 2 tables. And remember, union is used to combine the result set from 2 tables, 2 or more tables, to combine the result set. And how to combine this 1, 2, 4, 5? Again, it has to combine 2, 3, 4, 5 as well below these results, but it actually eliminates the duplicates when we use the union operator. And we wanted the combined results of these 2 tables. I wanted duplicates even. I just wanted to print all the results. So even with duplicates, I wanted to view the data. In that case, we can use the union all operator. So in that case, the result is 1, 2, 4. It will print 5, and whatever are there in the table 2, irrespective of either they are present in T1 or T2, it will be printed 2, 3, 4, 5. So all the duplicates will also be printed when you say union all between any 2 tables. And when we say union, only distinct values will be displayed from the two tables. This is the difference between union and union all. And when we use intersect, between two tables, so it displays only the common values between two tables. So common values here are 2 and 4, I guess. Okay, 4, 5 as well. These are the common values in two tables. So this is how intersect operator works. And when we use minus, it actually prints. So if you say t1 minus t2, it actually prints values in t1 which are not in t2. It prints the values only in t1, and that too the value should not be present in t2. Only such values will be printed. What are the such values? It prints 1 as 1 is present in only t1 and it is not present in t2. So you can see it cannot print 2 here, as you can see 2 is already present in t2. It will be skipped. 4 will be 4 will also be skipped as it is already present in T2. 5 will also be not displayed as 5 is also present in T2. Only 1 will be displayed here from these two tables when we use T1 minus T2. This is how minus operator works. Anyways, this intersect and minus are not supported in MySQL. We are going to look into union and union all here. Let me go back to the presentation. And there are some constraints to use union and union operators in database, in MySQL database and in any database. So you can read this. Let me read this constraint one by one. The union operator is used to combine the result set of two or more select statements. Fine, this is what we learned. So to actually apply the union operator, you need at least two or more select statements. Fine. And you can see each select statement with union must have the same number of columns. So this is very important. In order to combine so what is the union is doing? It is actually combining the results. And to combine the results, you definitely need the same number of columns. It's obvious, right? Like you might have like 3 columns in one table and only 2 columns in other table. You can't combine the result set of these two tables. So what happens to the third column value for the second table? So that becomes ambiguity, right? So in order to use union operator between any two tables, then like the select statement, in the select statement when we use the union operator, then the two tables should have the same number of columns. This is one condition. And the columns must also have similar data types. Obvious, right? So we wanted to just now we saw an example. Say for example, in this case I have this num1 and num2 as numeric. Fine. Say for example, num1 is numeric or integer and num2 is some varchar. We can't actually combine these two results as these two can't fit into same column, as these two are different data types. So as we are combining these two result sets into one column and we wanted to display it, that definitely should be of same data type. That is what it's mentioned here. And the columns in each select statement must also be in the same order. So columns also must be in the same order. So select some num1 from union. So you can't have any other order. So it has to know, MySQL should know that you are combining in what order you are combining. That has to be specified clearly. Say for example, let me write it here, some select num1. This is the syntax of it. Union from, say for example, tab1 union tab2. So let me directly show you one example here. This is anyway I already created this A and B table. You can see it here. Create table A has some two columns, yes name, and which is of varchar, and number you can see it here, integer, right? Likewise, we have some table called table B, which has number, which is of integer data type, and grade, which is of varchar type. Observe it carefully here. There are two tables. First table has varchar and integer data type columns. Second table has integer and varchar data types. Likewise, there are two tables. Now you can see it here. There are some values into it. A A table has these values, you can see it here, and B table has some values into it. Now we wanted to apply union operator between these two tables. How to apply that? We'll see that now. So let me go back. I have these two tables already created in my test DB. So let me show you that. My test DB has table A. Let me execute select star from A. And you can see these are the values of my table A, sname and num. Likewise, you can see the values from table B. These are the values. Now we wanted to combine, or we wanted to apply union operator between these two tables. So how to apply it? Let me get this here. And if you observe these two tables, let us actually select it here. You can see it here. S name is varchar num, and B table has num and grade. Varchar number and B has number and varchar. So how to actually write the union between these two tables? So let us see that now. Now we'll choose only the columns which are common, like which we wanted to combine. Out of these two tables also, we did not like combine all the columns from these two tables. We just wanted to combine some particular columns from each table. That is, we selected num column from each table. Select this num column from A, union, select num from B. And why we are doing this? As we can apply only union operator between two similar data types, and you can observe num is integer in two tables, and it is in same order. You can see as we have only one column, order doesn't matter, but it should be in same order. Say for example, if we wanted to combine, say for example, this A has S name, right? S name, and B has grade. So we should be having the same order, like it should have S name like this, and you can't have grade starting here. As you have here integer and varchar, you also need to have the same order here, num and grade here, like this is what we mean by union. So let me show you first combining of two same data types. And here you can see the values 10 11 12 14 13 15. So there are some values 10 11 12 14 here, and you can see 11 12 13 15. 12 is repeated, but you can see it here clearly. It doesn't repeat the number which is present again, as union operator eliminates the duplicates. Now let us see the same on union all. And we can clearly see here there are only six records written when we use union operator between these two tables. And we had eight we expect, but there are some duplicates here if you observe. So 12 is duplicate, and 11 is also duplicate. That's the reason we had only 6 rows here. But union all, just now we discussed, union all returns all the rows irrespective of it can be duplicates or not. So let me execute it. It also returns duplicates, and you can see here 10 11 12 14 are coming from table A, and 11 12 13 15 are coming from table B. And we can clearly see here 11 and 12 are repeated, as union all displays duplicates as well. So this is the only difference between union and union all. SQL joins. So what joins are? Joins are used for retrieving data from two or more tables. So this is what we did in union also, right? Then what's the difference between join and union is what we'll get. That question we'll get. So you can see it here. Join combines columns from two tables, but union actually combines rows from two queries. So earlier in unions, what did we see? It was combining the rows. So we had 4 rows from the first table, and it actually appended 4 more rows which it is getting from the second table. But here in join it is different. It actually combines the columns from the two tables. So that's the main difference. And how to write the joins and what are the different types of joins, we are going to see it now. Tables are mutually related using primary and foreign keys. So when we write the joins, so the condition is tables has to be mutually related. So what does we mean by relation is, we do have some concept of primary key and foreign key relationship between the tables, which we are going to see in the next session. But for now, just think of it like this. So in order to have join between any two tables, the two tables should have some uh, common column. Common column in the sense it need not have the same column name, but it has to have some common data between two columns. So and that has to be based on some relation. That relation we are going to see in the next session. But for now, you can just think of it like this. So it has to have some common column between the two tables which have some similar data in two tables. Only then we can use the joins. Even if you don't have that also, we can use the joins, but we will not get the results that we are going to see as part of the different types of joins. You can see it here. There are like different types of joins, like we have equi join, which is also called as inner join, or it's also called as simple join. We also have right join, left join, and this is also called as right outer join, left outer join. And the syntax will also be used like this in some other databases: right outer join, left outer join, and we have full join and self join. So we'll see all these joins one by one now. So to easily understand it, the joins, we can easily understand it with this diagram. So let's say, for example, we have some table 1 and it has some values. Let's, for simplicity, let's say, for example, we have two tables and each table has only one column, and the column name is some num id, and you can see it here in the first table. These are the values. You can clearly see it here. It has the values of 12, 14, 10 and 11, and that is represented here using this circle. And table 2 also has the same column name, and you can see these are the values it has: 11, 12, 15, 13. These are represented like with this tab 2 circle. And if you observe it, these two tables have some common information or some common rows, which are 11 and 12. That is represented here, the intersection. And you can see it here, like how to actually get the inner join. And what's the inner join is, inner join actually gets the values which are common to two tables. So, and how to apply inner join is, so you can see it here: select star from table 1, inner join table 2 on is the keyword we need to use on the condition. So what's the condition? Table 1 column should be matching with table 2 column is the condition we need to mention. So that what happens is, the columns which are common between the two only will be retrieved. Between the two tables only will be displayed using the selection when we use the inner join statement. And if you observe left outer join, so in the left outer join, what happens is, select star from table 1. Will be modifying instead of inner join, we'll be saying left outer join. Table 2 on the condition is same. So we always need to have some condition here on two tables, on some common. We said like join can be applied on two columns where where these two columns should have some relation or similar data, right? That we need to specify it here on table 1 column equal to table 2 some column. So when the data is same, such columns, such rows will be retrieved and join will be applied between these two tables is what it means. And you can see the result here. When we do left outer join or left join, what happens is, the results will be picked up, the common results will be picked up. Like when we had inner join, only the common data between two tables picked up, right? So in the same way, left outer join also, the common data will be picked up. Here the common here is information is 11 and 12, that will be retrieved, and then whatever the rows are there in the left table, that will also be added to the select statement. And you can see it here. 11, 12 is common, and whatever are there in the left table. Left table here is table 1. So 10, 14 will also be added to the result. So this is what left outer join. And with this, you can easily guess what right outer join will do. So select star from table 1, right outer join table 2 on condition should be definitely there on some condition. As we are using joins, there has to be some condition on the common column between these two tables, which can or cannot have some similar data. So that will represent it with this condition, and you can see it here. The common information will be retrieved first, and as it is right outer join, along with the common information, we'll also have the information which is left in the table 2. That is 13 and 15. You can clearly see it here. So this is what right outer join results us. And there is something called full outer join. So what does this do is the common information plus whatever the rows left in the left table and whatever the right whatever the rows left in the right table, all the information will be displayed or read using the full join or full outer join, which is not supported in MySQL, but it is supported in some other databases. This is about joins. Now we'll see this. So I already have this table 1 and table 2 created. You can see the syntax for it. If you want, you can actually use this syntax and create these two tables, table 1 and table 2, and insert data related to this example I'm going to show you now. This is my table 1. You can see it here. Table 1 has some information and table 2 has some data here, 11, 12, 13, 15. Now I'm going to execute these queries. Okay, first we'll write query on this. Select star from table 1, inner join with what table you wanted to do? Table 2 on what's the first column name? Tab1 dot num equal to tab2 dot num is the condition we need to specify. This is the syntax. So in order to join two tables, we need to write the condition like this. Select star from table 1, inner join table 2 on, this is the condition on the common column. Select star from table 1, inner join tab 2 on tab1 dot num id. Okay, it is num id or what? Okay, it is num id. It is not num. The column name is num id. And now you can see it here. So when we do inner join, so it actually it is resulting. We are saying star from tab 1 inner join tab 2. So it is giving us columns from both the tables. So you can see it here. So it is not appending it. It is actually showing you the columns from both the tables. And you can see it says as inner join returns only the common columns. You can see it here 11 and 12 are common. That is what it returned. Now let's use the same query and let's look for left join. You can say left join or left outer join, both are same. MySQL supports left join syntax as well. Now you'll see the difference. So you can see it here now. So from tab 1, this is the column. So when we use select star from tab 1, left join, tab 2 on this condition. So it retrieves on, just observe the left hand side. So it retrieves 11 and 12 common information as well as 10 and 14 which are coming from the left table. And you can see for the right table, these are null values as we are using left join. In the same way, when we actually use right join, you can see it here now. When we use right join, so the values which are coming from the right side table, so the common information will be displayed, and what are all the remaining rows left will also be displayed. when we use the right join. And as said, full join is not supported in MySQL. And it shows unknown column tab1 dot numid non class. So it says like actually full join is not supported. These are all about joins. Now let us see some practical examples with whatever data we have in our schemas. So you can refer this. So it says full join is not supported in MySQL. Now let us see some examples on this. So inner join or simple join or equi join, everything is same and it returns only matched records or common records. And now what we are going to do here is, let me first explain you customers and employees. All right. So there are two tables in my classic model schema, customers and employees. You can see it here, and it has employee number here. So employees table has employee number and employee information. In the same way, customers table also have customer information, and you can see it here. There is some sales rep employee number here. So what does this mean is, why does there is employee number in customer table is, so each employee here so is actually is in charge of one customer. You can just think of it like some relationship manager. So when we have some account in banks, so then we will be assigned some relationship manager, right? So in the same way, this customer table has some employee number, like each this employee will be uh, in charge of this particular customer, and more than one employee can be assigned customers. So you can see here the same employee has to handle or is in charge of more than one customer. So this is the relation between customers and employees table. Employees are the actual employees, and they have the information like their email ID, in which office they reside, who the employee reports to, the manager, and what's the designation. That and customers information has the customer information. Along with that, customer information also has the employee number, that is sales representative employee number. Like the employee who will be taking charge of this particular customer will also be present here. And why we are discussing this is, we wanted to join these two tables, and we wanted to use join between these two tables based on the common column called employee number. And this is the query we wanted to see now. What we wanted to see here is employee number, customer name number. So which employee number has what's the customer number for that particular for the particular customer number, what's the sales representative number is what we wanted to see. From customers table, inner join employees table on sales rep employee number equal to employee number. So just now we discussed like joins can be applied on some columns which should have like, though column name need not be same, but these two should be related. And just now we observed customers and employees have some relation, like what are the employee table information is there, employee number. So only these employee numbers will be present in this customers table. That's the relation we have it here. And you can see it here. We wanted to join these two tables on this common column employee number, and we wanted to look into employee number and customer number. Let me execute this query now. Okay, we are in testdb schema. We need to use classic model schema. For that, we need to say use classic models. Then the context will be set. MySQL will know that it has to execute the queries in classic model schema. Now let me execute this. Now you can see it here. So each employee and the customer number to whom he will be like the particular employee, this employee will be taking charge of this customer. This is what we can see it here clearly. Or else if you want, we can also display customer name as well. So you can see this particular employee number is taking care of this particular customer. That is what we can find it out using joins. And this is the example, practical example. You can see it here. So the use of joins. And what did we do here? For that, we just joined two tables on some common column information. And whatever columns we wanted to display between between these two tables, in these two tables, employee and customers, whatever information you wanted to display, that you can mention it here. And if the same column name is there in two tables, then we need to add some alias to the table and specify the alias here. Like say for example, this employee number is present in same table. Employee number column name is same in two columns. Then we need to specify which employee number you wanted to display here. In that case, we just need to specify the alias to the table. Let's say for example, like customers. For customers table, I can have alias as C. Employees table, I can have E. And then employee number, I wanted to display it from employees table. Then I need to specify it as E dot employee number. Get the employee number from E dot employee number, even though employee number column is present in both customers and employees, is what I can say. But in our case, it was different actually. It was like sales rep employee number and employee number. Sales rep employee number column is present in customers table and employee number was present in employees table. So we didn't get any ambiguity. But why I'm saying this is, in case if you have same column name in two columns also, so this is how you need to resolve the ambiguity. You just need to make sure inform MySQL that to use to use this column from the particular table using the aliases like this for the tables. And you can see the same data here. So this is the use of inner join. And here, if you observe, only the common information, like whatever is matched between these two, only that got displayed here. And you can clearly see here. So there are like only 100 rows written, even though like the customers, let's say for example, this employee table, there are 23 employees and there are 122 customers. So even though there are 122 customers, so if you observe, this query is returning only 100 rows. So there are some customers who don't even have the sales representative employees. That's the reason we are not getting the matching value there, and we are getting only 100 rows written. And for that, let me show it here. You can see here, for some customers, there are null values for whom there is no employee sales representative to assign. So those results will not be matched. As you can see here in the employees table, employee number is never null here. So only the matching records will be displayed here in the, as we are using inner join. Next, let us see an example on right join. So here in the right join, it returns the matched records, between the two tables, and also unmatched from the right table. Unmatched from the right table. So here in this case, it is employees. Let me go back. So you can see we are using the same query, but this time we are using right join. So what does this mean is, earlier it returned only matched records, right? Now it is going to return the same matched record, this 100 records, plus some more records which are present in the employees, table. So let me execute this. You will get it. So you can see it here. The matched 100 records were there. Along with that, there are some 8 rows, 8 records which are present in my right table, meaning my employees table. There are some 8 records which are not present in customers table. All those records are also displayed here, and we can clearly see it here. I'll show you that. So these are that customers, that employees. So which has, here also we have some null. These are the employees which has the these are the employees who are not assigned to look in charge of any customer. So, but you can just understand the query like this. So we have a query here where when we use a right join between these two tables, on some particular condition, the matching records of these two, the matching records for this condition will be retrieved, and along with that, whatever are the rows left in the second table or the right table. So we call this, when we have two tables and we have joint syntax written between these two tables, we call this table as left table and this table as right table, and whatever the records left in the right table will be added to the result set. And these are the results. You can see it clearly here, which are coming from the employees table. And for the same, we can have left join as well. So in the left join, you can easily understand. So it is just reverse of it. Like both, you can see returns matched records plus unmatched from the left table. So what is the left table here? It is customers. So the matched records are 100 plus whatever are the remaining rows left for the customers, which are not matched, will also be added here. And you can see here there are 122 such rows. And for that, you can see as there are no value for them, it displays as null. But it is actually getting those unmatching customers also. See, you can see it here. All these are unmatched customer numbers. Why we are getting this? Why didn't we get this earlier in the inner join is? So here we are using left join. So all the matching records, you can see the below ones will all be the matched records, 100 records, and all the remaining ones are the unmatched records which are coming from the left table. And as these are coming from the left table, so you can clearly see it here, those don't have some matching column here. That's why, but it has to be displayed. That is what we are saying the select class. So it doesn't have any value, so it just displays it as null. So this is all about left join. Next comes self join. So say for this, we can take an example of like printing employee details who is manager of other employees. So what does that mean is, let me show you. We have employees table here, and you can clearly see here each employee has first name, last name, his email ID, where the office code, whom he reports, like whom the employee reports, and you can clearly see here the employee number here and who this employee reports to. This is the actual designation of the employee. We only have the reports to as employee number, the manager. So if you take one entry here, let's take this entry. So 1102 is one employee. The employee name is some Gerard, and this Gerard reports to an employee with ID 1056. And we can look into 1056. Here itself it is 1056. So Gerard reports to 1056 employee number, that is 1056 employee name is Mary. So this is the relation, we have it here. Within the table itself, we have some relation in the sense, some common column, we can see it here clearly. So employee number and reports to is the have the same information. Now we are going to join this, um, join these two columns. So how to join the two columns which are in the same table? For that, we can use the self join. So what does self join mean? Does is, you can see it here. So even though we wanted to join like two tables, so if we wanted to use any join, we need two tables, and here we are considering two tables as the same table. You can see it here, as we wanted to write a condition on the two columns which has some common information, but unfortunately these two columns are present in the same table, but still we wanted to write a join condition. Then how to write it? Then what we'll say is, I wanted to print some information from two tables. Let's come to this later. From employees, employees E, employees M. So this is how we can write the self join. So you can see it here clearly. From employees E, employees M is the self join. So even though it do not specify the condition, it is self join. So we wanted to print, get the values from these two tables, and you can see it here. I am repeating employees table two times, and there might be some ambiguity as these two tables are same. I am having some different alias here. One represents E and one is representing M. And my condition. So we definitely need have some condition when you are using joins. So I'm having some condition is my m dot employee number should be equal to the employee who reports to. So m represents manager, manager employee equal to employee who reports to. These two has to be same. Then get some information from these two tables is what we are saying. That information we are saying it here using the aliases of these two tables. For example, so let me give you an example for this. There can be some employees like this, right? Who is reporting to some employees like this. So now what we wanted to find is we wanted to find there can be some employees like reporting to maybe 1006, 1004 is reporting to this like this, but 1006 might be reporting to someone else, right? So now what we wanted to have is uh, the employees who are also managers is what we wanted to print. So these are all 1006 is actually an employee. Some of the employees are reporting to 1006 and again 1006 will be reporting to some other employee, right? Likewise, like 1008 will also be reporting to someone else. So for example 1009 like this. Now what we wanted to find is who are the employees as well as managers. We wanted to print such employees. This is what we wanted to find. That's the reason what we are using this self join and having the same table name two times, and we are joining within the table itself, and within the table itself there are like two columns with two like different names, and for that we are writing the condition on these two columns which are all having the common similar data, and then we wanted to print some information here. And let's look into the information now. So e dot employee number, I wanted to print some employee information here till here, employee number, first name, the job title of that employee, and the manager of that employee also I wanted to print. And also wanted to, I'm interested in displaying the manager information. What's the manager name and manager title? Who the employee reports to. This is what we wanted to display. If you observe the actual employees table, it will not have this information. It just have employee number, some employee information, and then it will have only the reports to or the employee number uh, or the manager number. The manager's employee number will be present, but the actual information of the manager will not be present for each employee, and that we wanted to find it now. You can see it clearly, and for that I'm displaying it here using one of the aliases from these two tables. Let me execute this now, and now let us observe. So you can see it here. This employee 1056 Mary has job title VP sales, is reporting to a manager with employee ID 1002. First name is Diane with job title president. Likewise, there is another employee, Jeff, with the name Jeff, who is also reporting to the same person. You can see it here with this same employee ID and same name reporting to same. And now, if you observe, I am interested to print the employees who are also managers. That is what we started with. Print employees details who is manager of other employees. So here Mary was considered as employee. Now if you observe the third entry, Mary was displayed as the manager now. So that is what we wanted, as Mary was employee and also manager. Now we wanted to print that information. So Mary is also manager for some of them. So you can see it here. These are the entries. These are the three entries reporting to Mary. Now again, if you observe from these three entries like William, Gerard, Anthony, again Anthony is manager of someone else. You can see it here. These are the entries. These are the employees who is actually reporting to this Anthony. Again, like from this list of whatever I highlighted, there can be someone who is like manager of some other employees. Like this, the list goes on. How did we prepare this list is, we actually wrote some join condition on some common column information called reports to. You can see the, again I'll explain you this. So there is reports to an employee number which has some common information. We wanted to join, write a join on this condition. We wanted to write a join on these two columns to retrieve some information. So what information we wanted to retrieve? We wanted to read employee details, who is manager of other employees. That is what we did using the self join. So this is when we write it like when we write a condition on the same column, on the same table, different columns, it is called as self join. And this is how we can retrieve the data using the self joins. Subqueries. What is a subquery? So we might need in sometimes like we might not get information what we need with a simple select statement. We might need to write some logic, like we might need some condition, write a condition, and for that condition to match, we might need to have another select statement to be written, where we'll get some data from that select statement, and with that data we'll pass it to the another select statement writing some condition. What do I mean by that is, so you can clearly see here, subquery is a query within a query, meaning it has two parts. It has outer part and inner part. Any subquery has two parts, outer part and inner part, inner query. So it has we call it as two parts, outer query and inner query. We'll see. Output of inner query becomes input of outer query. So this is what I was mentioning. So we run some select statement, we get some results. This result will pass it to some other select statement as a condition to it. So this is what we mean by inner query becoming like input of outer query. So there are like two types of subqueries: single row subquery, which returns a single row, and multi-row subquery. So we can use in, any, all, where we'll get many results from this. So we'll see it one by one. First, we'll see single row subquery. What are single row subqueries? Say for example, we wanted to display customer number who made highest payment. So in like our payment, so we have some table called payments table. Let me show you payments table. So payments table has customer number. This is the customer number who actually gave this, who gave actually check with this check number. This is the payment date and this is the amount paid. And now what we wanted to find is display customer number who made highest payment. From this, we wanted to find the highest payment amount from this table. How to find the highest payment amount from this table? So for that, what we are going to do here is, we are going to find the maximum amount from the payments table. Let me show you. Where is my payments table? Okay, you can see it here. This is the payments table. From this, we wanted to know the customer number who paid the highest amount. That is what we wanted to find it out. So for that, what we can do here is, you can see it here. Select maximum amount from payments. If I execute this, fine, I'll get the maximum amount from all the payments. But from this, what I wanted to do, I wanted to get the customer number from this. So how do I get the customer number who actually paid the maximum amount? But this query actually select maximum amount from payments, gives us the maximum amount from the payments table, fine. But we wanted to also print the customer number who actually pays the maximum payment, paid the maximum payment. So for that, what we need to do is, now we got the maximum payment, fine. Now we can use this amount, max amount option or this result, we can use it in some condition. So condition, how do we write it? We write the condition using where class. So you can see it here. Select some columns from my payments table where my amount is equal to maximum amount from the payments, and maximum amount we just know calculated. This is the number. So it is like this query is almost similar to writing this amount here in place of this, and this we know, like if it has some number here like this, how does it that execute? We know it executes based on this condition. It actually gets the columns, rows when the amount is equal to this one, right? So likewise, we are writing this query. So this is what we mean by inner query. This is what represents the inner query. Let me write it here. This is inner query. This is inner query. Inner query is executed first, and it actually gives us some result. Then that result becomes the input to the outer query. This is all outer query. Sorry. This is the outer query. Remember. And to execute the outer query, we are depending on the inner query for some information. And what's the information here? We wanted the maximum amount from the payments. That is what inner query will be executed and will give us the result. And that result will become input to the outer query. So this is the result, right? So this result will be passed here to the outer query. And it has some condition. So this value, this result will be used for this condition, and then the whole query will be executed. This is what it executes the subquery. And in the subqueries, always remember, first inner query will be executed, and then the result will be passed as the input to the outer query. So why are we calling it as subqueries? You can see it here. Within the query, we have two select statements. Till now, we work with only writing queries with one select statement. Unless like for the union, other than that, so for all the statements, whenever we are writing the queries, we used only one select class, one select statement, right? So, but here if you observe, within the select statement itself, we have like we are writing another select, which we call it a subquery, and this actually gives us some result. That result we are passing it to some the outer query. Now let me execute this, and you can see here now we get the amount we got it fine. We also got the customer number, and we also got the check number of the customer. So this is how we can use subqueries, like to find out the like maximum amount paid by the customer. Who is the customer number who paid the maximum amount? For that, what did we use? Till here it is fine, but we wanted the amount, like maximum amount. What's the maximum amount? For that, we use the subquery. Select max of amount, and max of amount we learned what max does. Max returns the maximum amount from this payments table. So whatever the amount column will have some values. Among them, what's the maximum value picked up will be picked up when we use the max aggregate function, and this maximum value will be used for this condition where amount equal to this one. This amount equal to this value, the result of this subquery. Then it will actually match with this, and whatever the filtered rows that will be displayed here. This is the use of subqueries. Now let us see some more examples on subqueries. Now I wanted to find second maximum credit limit from customers. How to do that? So if you observe customers information, let me go to customers information. You can see the credit limit column here. Each customer has some credit limit. Let me sort it out. So just to sort it out, you just need to click on this column once, single click, and if you do again a click, it will come in the descending order. One click, sorted in ascending order. Again one click, other click, you will see the value sorted in descending order. This is the highest value. This is the highest credit limit by some customer number called 141 fine. Now that is not our requirement. if this was our requirement, we would have just written select maximum of credit limit from customers. We would have got this number, and to get the customer number for it, we would have used the same query. Just now we used that, right? So select maximum amount, we can use that query, but our our requirement is not that here. If you clearly read this, we wanted to get the second maximum credit limit from customers. This is what we wanted. For that, what we need to do here is, first of all, we'll execute. Let me execute this. Let me show you an example here. Say for example, we have some information like this. Let's say for example, credit limits are like some 1,000, 3,000, some 5,000, some 7,000, like this. There are the credit limits like this. Now we wanted to find the second maximum, second highest credit limit, right? Second maximum credit limit. What is the second maximum credit limit? This is the first one, first maximum credit limit. But we wanted last but one or the second maximum limit. So if you sort this, it will be in 7531 like this, right? So we wanted 5,000 to be displayed, not 7,000. If we need 7,000, it was easy. We'll just write maximum, we'll use aggregate function max, and we'll easily get this maximum credit limit. But this time we wanted to display second maximum credit limit. So how to do that? How to actually read this second maximum credit limit? Now, for that, what we can do here is, we'll actually get the, we'll write a query to get the highest itself, highest maximum credit limit. And how do we do this? We can use max of credit limit, which actually returns as the maximum credit limit, that is 7,000 in this example. We'll get it, fine. Now what we are going to do here is, we'll write another select class outer query where we'll say that I need a I need the maximum of credit limit. No doubt I wanted to get the maximum credit limit from the same table, but it has to be less than this value, is what we can say. So if you observe, in this table, the maximum value is 7,000, and what we are writing, the condition, I need the maximum value from this table, which is less than this value, is what we are saying overall. So what does that mean? We will definitely get what's the, so from this list of table, if you observe from this list of table, 1,000, 3,000, 5,000. So less than, maximum should be less than 7,000 is what we are saying. Among this these remaining values which are like less than 7,000, definitely 5,000 will be lesser than 7,000, right? First it will come in. So 5,000 will be displayed. So let me explain it again. So there are like 1,000, 3,000, 5,000, 7,000 values. We wanted to find the second maximum credit limit here. And how we find that is, we'll first find it out the maximum one. Maximum one is 7,000 here. Now we have it. We have it. Fine. Now we wanted to find the second maximum credit limit, right? For that, what we'll write it here is, we write a query maximum from this table itself. We write it maximum, but it has to be less than some value, is what we are saying. So it has to be less than, what's the value? 7,000 is what we'll write it. And if it is less than it, we need maximum, but it has to be less than 7,000. So then it will definitely get the next highest value in the table, that is 5,000 here. So among the remaining values, which one is the less than 7,000? The immediate one, 5,000. So that is what we'll get it here. So, and to write that, for that, what we need to do here is, let me show it. Select maximum credit limit from customers. This gives us the maximum credit limit, fine. But we wanted the second highest one. So for that, what we are going to do here is, we are going to write the same condition here, which is where my maximum credit limit or my credit limit has to be less than the actual maximum value. Now you can see the second maximum value will be displayed here, and you can see it here. You can compare it with this. So this was the first one, this was the second one, and this is what we got it. And how did we get it? The inner query, what it does, it does get the highest value. So the highest value was this one, right? So it just says, I can put it here. This was the value. Credit limit less than this one. So I need maximum maximum credit limit from customers, but it has to be less than this value. So less than the highest value in the sense. So among all these columns, which is less than the highest value, the second one. And these are all like less than, but we wanted the maximum out of this. That is what the condition here is. You can see it here. So the credit limit should be less than this value. Again, if you write only less than here, so we'll get all these columns, as all these columns are less than the maximum credit limit. But among all these, we are getting the highest value. Here also you can see it here from 1000, 3000, 5000. So we have list of values, but among this we wanted to find the maximum value. Remaining values we wanted to find the maximum value. That is what we want. We are finding here. And from the remaining values, if you observe, from here all the remaining values are lesser than the maximum value. Fine. Among the leftover credit limits, what is the highest value? This is the highest value. That is what we have written the condition here. So select max from customers gives us this result, and then we are actually finding the maximum credit limit from customers, where credit limit should be less than my maximum value. This is how we can find the second maximum credit limit from the customers. Next, we'll see third maximum credit limit. So how to do that? Again, we need third one, right? So for this, we'll write another subquery. You can see it here. There are like three queries now, two subqueries, and first subquery it will return first highest. And you can see in the second subquery, it will return like just now we saw this query will return the second highest. Then we'll repeat the same and less than the second highest value. This is what we'll write it here. With that, we'll get the third highest. So if you see in this 1000, 3000, 5000, right? So finally, we'll get 5000, and this 5000 we are writing another condition here from 1000 and 3000. I need less than 5000, the values which are all less than 5000. So the values which are less than 5000 will be 1000 and 3000, and among them this I wanted the highest value, so it will be 3000. Likewise, you can see here customers table. So from these three, less than this value, it will be second one, and I wanted among these all these values which are all less than 210500. All these are the such values. Among this, the highest value. So it will be 141300. Let us execute this. And we can see 141300 got displayed here. This is how we can find the third maximum credit limit. So this is very important question in an interview point of view. So mostly you will be given some employee table which has some salary column, and you will be asked to find the second highest salary or third highest salary. So you can show the query like this. So you can write the query like this. This is all about single row subqueries, and also we have some more examples. Say for example, if you wanted to find the credit limit of customers whose credit limit is greater than the credit limit of customer whose customer number is 450. So here just condition here. So if you observe, first we need to read the query or problem statement here. Find the credit limit of customers whose credit limit is greater than, fine, greater than, then read it as separate. The credit limit of customer whose customer number is 450. First we should be writing the select statement for this, or first we need to write the condition, this condition greater than the credit limit of customer whose customer number is 450. And for that, how do we need to write is, first we'll write this condition, select credit limit for customers where customer number equal to 450. You should be reading in the reverse order first, then this becomes the inner query, and from this what we wanted to find the credit limit of customers whose credit limit is greater than. Select credit limit from customers whose credit limit is, this is what it says, greater than what, greater than, fine, credit limit of customer whose customer number is 450. Select credit limit from customers whose customer number is 450. So whose customer number, how do we filter it out? Using the where condition here, where customer number equal to 450, fine. And what we wanted the such credit limit which is greater than this value. That's the meaning of this statement. So we need to read the query statement clearly, and then we need to write the first subquery, select credit limit of customer whose credit customer number equal to 450. First execute this. So this is the credit limit of customer whose customer number is 450. You can also see it here, whose customer number is 450. Yeah, this is the column, and we can see it as 77600. That is what we got it here, fine. And we finally what we wanted the credit limit of customers whose credit limit is greater than this value. So all this is representing one value, and we what all we need is the credit limit greater than this value. So this we know, it is easy. Select credit limit from customers where credit limit greater than some value. All that we need is this value, and this value we can write the condition according to the problem statement. And this is what we did. And finally, after executing the whole query, you can see the result here, which is all like greater than some particular credit limit of this customer. This is another example on single row subqueries. And if you observe, like till now, whatever we are writing these queries, they are returning, the subquery is returning only one value. Remember that. Next, we are going to see multiple row subqueries. So another example. So if you wanted to actually display customers whose payments are less than the average payment, how do we find the average payments from the payments table? We just need to write this statement, right? What is the average? Let's go to payments table, and payments table have some amount column, and we wanted to find what is the average of this this amount column. We just need to use the aggregate function called avg. With that, you will get the average amount from the payments table. Let me execute this. So this is the average amount, fine. Now we wanted customers whose payments are less than. So I wanted the customer information whose payments, whose amount is less than the average amount. This gives us the average amount, and we just need to write the condition like this. Select columns from payments table where my amount is less than a particular amount. That particular amount is what it said, average payment. And average payment, we can calculate it like this. Select average amount from payments. So till here, we know how to write it. Like it actually gives us the information. Displays customers whose payments are less than, whose payments are less than. So till here, using the problem statement itself, we can write it. What we need to write in the subquery is we need to read it carefully. Less than the average payment. So then we need to add this statement as the inner query. And let me execute it. So these are the customers who has the amount less than the average payment, average amount from the payments table. These are the different customers. This is about single row subqueries. Now let us understand multi-row subqueries. Till now, what did we do? Whenever we execute this inner query, right, we always used to get one value. So in any case, we used to write some condition, or we used to write some aggregate functions, and we used to get one value here, and that value will be anyway replaced here. And this the outer query will use that as a condition, and we get the results here. This is what we saw. Now what happens, like if my this select query, inner query, returns more than one row as the result. That we are going to see now. Now, for that, I'll take this example. So, display employees who work in offices located in the USA. So, we know employees table has employee information along with their office codes. Now, we wanted to write a condition, write a query here where offices are located in USA. So, how do we know this office codes belongs to which country? For that, we have another table called offices. Let me show you the offices table here, and each office code, city is mentioned, country, state, country, postal code is also mentioned. Territory is also displayed here. You can see it here. This offices table has the entire information of that each office. And you can see now what we wanted to write the condition, display employees who work in offices located in the USA. And how do we actually write the condition here is, we are going to get the countries from this, like each office code. How do we get the countries here? Using this offices table, we are going to write a query to get office codes which are all belongs to the country USA. That is easy, right? Select office code from this offices table where country equal to USA. That's how we get the office codes which belongs to the country USA. That is what I have written here. So you can see it here. Let me take it here. This is the subquery. First of all, what we wanted, employees who work in offices located in the USA. So first we wanted to get the office codes which belongs to the country USA. That we'll get it from the offices table. Now we have some office codes. All these offices are present in the country USA. Now we have this result set. Let me execute this first. These are the different offices which are present in the country USA. This information we have it. Now we wanted to get the employees who are all present in the, who works in offices located in USA. Now we have the office codes located in USA. We just need to print the employee information. So for that, what we can do, select employee information from employees, where my condition, where my office code, which is there in employees table here clearly, should be in the result set which executed just now. So if you remember, in operator is used to match more than one, if you have a list of values to be matched with, then we can use in operator. So in office code 1 comma 2 comma 3. So this all query will be replaced with this result set 1 comma 2 comma 3, and this office code, if it matches 1, either 1, 2 or 3, then all such employees will be displayed here. The employees information who are all belongs to the office code 1, 2, 3 will be displayed here. You can see it here. And just for our readability, I am also printing office code. So you'll only see office code which has 1, 2 and 3 here. This is how we can write the multiple row subquery. So this is just the replacement of 1, 2, 3. So you can just think it of like this. Even if you remove this and write it as 1 comma 2 comma 3, both are same. It also returns the same 10 rows. You can see it here, same 10 rows. Only that you don't know how to calculate this. How did you know this 1, 2, 3? Only when we executed this query, we came to know that. That's the reason we are writing this query here. We are not finding this manually and entering it there. We are just writing the same query here, how to find the office codes, and just replacing it with here. And this becomes inner query, and this is how it became input to this outer query in the list of these values. Now let us see another example. So display the customers whose credit limit is greater than at least one customer in country Finland. So what does this mean? Again, we'll go back to the customers table. So let me go back to the customers table, and if you observe, customers table have the information of customer and their address as well, and the address has country as well. Each customer country is also specified here, And what is the query we wanted to write? We wanted to display the customers whose credit limit is greater than at least one customer in country Finland. So first we need to write the display the customers whose credit limit is greater than. Till here it is fine. We know we can easily write the query like this, whose credit limit is greater than, meaning you can write the condition like this. Next, but if you observe at least one customer in country Finland, it should be greater than at least one customer in country Finland. So select credit card from customers where country equal to Finland will be our condition. So we need customers who belong to the country Finland, their credit limit we need it, and at least one customer in country in the sense. So we will be using any keyword here. So any in the sense in represents like our condition, right? So any represents it's all almost like in, but any is even if one also one matches, one of the values matches, then it will be treated true, and then you can execute it you can consider that value for the condition. So let me execute this first. So these are the credit limits from customers whose country is Finland. So there are like three customers who belong to Finland country, and these are the credit limits of these customers. And now we wanted to display customers finally whose credit limit is greater than any of these three values. Any of these three values in the sense like it can be greater than this value, or greater than the first value. So all such credit limit customers we wanted to display. That's the meaning of this. Display the customers whose credit limit is greater than at least one customer in the country, and for that we can use any operator here. So all these three values will be replaced here, and if each credit limit of the customer will be verified with these three values, and if that credit limit is greater than any of these three values, that will be selected. So you can see there are like 38 such rows here, and the actual customers are I think 122 rows. From the 122 rows you can see the customers whose credit limit is greater than at least one customer from the country Finland, and any is like any of the value, and we have something called all. So if you just replace it any with all, so it has to be greater than all of these values. Let me execute this, and you can see it here. Now it returned only 25 rows because the condition here is it has to be greater than all these values. It is like you can see it here, credit limit is three values, but it has to be greater than all values. All values in the sense all this, it has to be greater than all these values. Only then this condition will be true. So to keep it simple, any represents the minimum value. The minimum value will be picked up. All represents the maximum value. That's how we can understand. This is about multi-rope subqueries, and we have two more examples. Let us also discuss that. So query to get customer name of the order. So if you observe, let me show you the customers table and orders table. Where is my orders table? Yeah. So this is the orders table. Order number, it has order date, required date, some shipped date, status of the order, whether it is shipped, disputed, cancelled, that one, comments, customer number. Fine, we have this. But I wanted to print the customer name as well. See, I have customer number here. Fine, I have the customer number and all the order details are displayed here. Along with this, I also wanted to have customer name displayed here. So only that is missing. So how do we get that? We get that using, so we can write the query like this. Select order number, ship date, all this we'll get it from the orders table, fine. But we wanted to get customer name also. For that, if you observe, we write one query in place of a column itself. See how does that will be evaluated. we wanted the customer name, right? So if you look at the highlighted part, select customer name from customers, where customers dot customer number equal to orders dot customer number. So it is like similar to our inner join. So even though we are not doing inner join, if you observe, it is like it is actually inner join. We are actually matching the rows from the customer table with the orders table. Customers dot customer number equal to orders dot customer number. That is, orders has one customer number column, and customers also have some customer number column. So if these two are same, then get the customer name from this customer table is what we are seeing here. You can see it here. That is what it says. Let me execute this. You will come to know. It says where customers dot. Okay, it doesn't have this order table, right? Okay, we can say execute till here. I will show you by writing inner join on from customers inner join orders on. These are the customer names. So we are joining like from customers and orders based on the customer number. So when do we write the join? If we have some common information between two columns in two different tables. So there are two columns in these two tables which have some similar data, and it has same column name. So that's the reason we are using the alias name here. Alias name can be table name as well. So this is what we have written here, and you can see here this is what it will be replaced with, and you'll be getting the customer name as well from this query. And for that I am using some alias here. Let's execute this. So you can see here from both the orders and customers name, this customer name, how did we get it? This query got evaluated and we are getting the customer name for that, for this order. So the only thing we need to note here is, so instead of the column name also, so the column also you can write one select query itself. So till now we directly use the column name here, right? So instead of that, you can write a query which actually returns one column. So you can have some alias for that and include it in the place of one column itself. So this is how we can use the subquery. Subquery used in place of a column. Like this also we can use it. And the last one is query to find the customers. This is just like a combination. So query to find customers whose credit limit is less than maximum credit limit. Fine, till here it is one part, and greater than maximum credit limit of customers from Denmark. So whenever we see a query like this, we need to divide it according to the statement. So what does it say? Let's go it from last to top. So greater than the maximum credit limit of customers from Denmark. So credit limit has to be greater than maximum credit limit of customers from Denmark. So just note this maximum credit limit of customers from Denmark. So for that we can write maximum credit limit from customers where country equal to Denmark. First we will complete this query. You can see it here. Let me break it down. So you can see here, select maximum credit limit from customers where country equal to Denmark. It has to be greater than that. So you can see it here. Greater than the maximum credit limit customers from Denmark. This we are done. And you can see it has to be less than the maximum credit limit. So for that, we can write another condition, like you can go and write it here. Credit less than, select maximum credit limit from customers. And this part we can clearly see query to find the customers whose credit limit is less than. So this part we can write it, select some customer information from customers where credit limit less than, what is less than maximum credit limit. So maximum credit limit, we can find it using max credit limit from customers. And so and is replaced with and itself directly, and it has to be greater than maximum credit limit of customers. Okay, till here it is fine, but we have some condition from Denmark, so we are including where country equal to Denmark. So this is how you need to break it down, the query, and write it down, and the entire query statement itself will tell us how to write the query. We just need to read it carefully and replace it with the queries, and this part will actually return one value, and with this becomes one condition, and there can be more than one condition in the where class. So you can see it here, here we have another condition, so where these two conditions has to be satisfied, as we are using and condition. So with that we'll get some information here, the required information. So you can see it here. There are some customers whose credit limit is less than maximum credit limit, fine, and it also has to be greater than the maximum credit limit from the Denmark, customers who belong to Denmark. So this is the maximum credit limit from the customers who belong to Denmark. So the value should be greater than this, but it has to be less than the actual maximum limit from the customers. It has to be less than this, and it has to be greater than the earlier one. This is just that. So the earlier one will be replaced with this, and the maximum credit limit will be replaced with this. So two numbers will be replaced here, and where credit limit less than this number and credit limit greater than the other one number. So it is as simple as such. So it just evaluates that values and writes a condition here, and we'll finally get the result like this. Like this we can write any number of like conditions here, and make much more complex subqueries also. So we just need to read the query carefully, what we wanted to do, and slowly start building the queries, writing the inner queries. So this is all about subqueries, and in this session we discussed about, we started with group by, we discussed having, we also having class should be followed by group by class, and we can also use order by class to order our columns, to sort our columns in either ascending or descending order. And then we saw union all, then we saw joins, 5 types of joins, and we just know some subqueries as well.